Let's review the answers to the warm-up. The first problem, 2x plus 4 equals 24. The solution was x equals 10. The second problem, m over 3 minus 3 equals negative 6. The solution was m equals negative 9. The third problem, negative 3 times the quantity p plus 1 equals negative 18. The solution was p equals 5. If there's one of those that you did not get correct, please pause this video and watch the next video with the explanations. You can resume this video at about 40 seconds to continue after you've watched those explanations. If you got them right, just keep watching this video. All right? Please make sure you watch this whole video. There's some information about solving inequalities, which we haven't really discussed yet this year. And even if it's something you've seen in the past, I'd like you to watch this whole video. All right? When we solve inequalities, first of all, an inequality is like an equation, except that we have an inequality symbol, such as greater than or equal to, less than or equal to, or less than, sorry, or less than or equal to. What we need to keep in mind is we're going to follow the exact same steps we use when we solve an equation. So the only exception to that is if you multiply or divide by a negative, you'll reverse the direction of the inequality symbol. We also need to graph our solution. All right? When we graph our solutions, if we have just greater than or just less than, we're going to use an open circle. And if we have greater than or equal to or less than or equal to, we're going to use a filled in circle. Okay, so if you want to draw those little angry faces, that sometimes helps me to remember which circle to use. All right, so the steps that we're following are the same. And if you notice, these steps are very similar to your warm-up problems. So 2x plus 4 is greater than or equal to 24. I want to find all the values of x that make that true. Just like if it was an equation, I can't touch that 2x until that 4 is gone. So I'll subtract 4 from both sides. I'm pretending it's an equation, but instead of an equal sign, I've got that greater than or equal to. So that leaves me with 2x on the left is greater than or equal to 24 minus 4, which is 20. To finish solving, I'll need to divide both sides by 2. And that gives me x is greater than or equal to 10. And there's my solution. What I'm saying there is that if I pick any x value that's 10 or bigger, this statement will be true. So let's just check a couple just so you understand. If I pick x equals 10, the left-hand side of this equation becomes 2 times 10, which is 20, plus 4, which is 24. If I pick, let's take 100. That's a number that's bigger than 10. If x is 100, I'll take 2 times 100, which is 200, plus 4, which is 204. 24 is greater than or equal to 24. 204 is greater than or equal to 24. If I pick any value less than 10, this will not be true. So for example, if x is 9, 2 times 9 is 18, plus 4 is 22. It is not true that 22 is greater than or equal to 24. It's less than 24. So that's exactly what we're looking for. Now, whenever we graph inequalities, we need to, or whenever we solve inequalities, we need to graph them as well. Now, when I printed this paper, the number lines for graphing got cut off at the bottom. So I'd like you to draw your own number line in, please. And label it. Here's the thing. You only need to label 2 numbers. You always need to label 0. So let's find a spot for 0. I'm going to put it right in the middle. And you always need to label whatever number is involved in your final answer. So I'm going to call this our critical value. It's the most important number in this situation. So all I need is 0 and my critical value, which in this case is 10 because I said x is greater than or equal to 10. All right. So when I graph this, if you recall from before, I was using a greater than or equal to sign. So I'm going to use a filled in circle. So the way I figured this out is at 10, I'll put a filled in circle. I want all the numbers where x is bigger than 10, including 10. So I tried a couple numbers here. I want 10, I want 100, I don't want 9. I'm going to be shading in the direction that's away from the 0 because I want the numbers where x is bigger than 10. Let's take a look at this next problem. Once again, I'm following the same steps I followed when I was solving a similar equation. So I want this m minus 3 totally by itself. To make that happen, I need to add 3 to both sides. So I'll put plus 3 on the left, plus 3 on the right. That gives me m over 3 on the left is less than negative 6 plus 3 is negative 3. Just like before, to finish solving, I need to multiply both sides by 3 because I was dividing. Now I need to undo that by multiplying. That leaves me with m on the left is less than negative 3 times 3 is negative 9. So this time I want all the values where m is less than negative 9. So let's just do some quick checking. If I have m equals negative 9, then I'm looking at negative 9 over 3 minus 3. So negative 9 thirds is negative 3, minus 3 is negative 6. Here's the thing. If this was an equation, I'd be all good. But since it's an inequality, it's not true that negative 6 is less than negative 6. So I'm going to put a slash through that less than sign so that my statement that I wrote is true. So at negative 9, this is not true. I want the numbers that are smaller than negative 9. So let's try negative 12 instead. All right, and I'm picking negative 12 because it's a multiple of 3. So m equals negative 12. That'll give me negative 12 thirds minus 3. Well, that's negative 4 minus 3 is negative 7. And it is true that negative 7 is less than negative 6. So I'm going to shade in the direction of the negative 7. When I set up my number line, again, the only values I care about you labeling are 0 and my critical value, which in this case is 9. So here's my 0, or sorry, negative 9. Negative 9 is to the left of my 0. And here's what I want. I want a hollow circle at negative 9 because that is the value I care about, but I'm not including it in my solution set. So I'll put a hollow circle at negative 9. And I'm going to shade to the left because I want the values where m is smaller than that. So when m was negative 12, we got a true statement. So that means I'm going to shade towards where the negative 12 would be, which would be to the left. Now, before we try this last problem, I'd like to highlight one thing. So if you have a highlighter, great. If not, use your, underline this. If you multiply or divide by a negative, reverse the direction of the sign. So that's going to come in really handy right now. All right. I'm going to solve this by first dividing. All right. I know I can't touch this p plus 1 until that negative 3 is gone. If you're confused about this method, go back and watch that next video about solving the equations because I explain it more there. So I need that negative 3 to go away. I'm going to divide both sides of my equation by negative 3. When I do this, or my inequality, sorry, when I do this, on the left I have p plus 1. And on the right, negative 18 divided by negative 3, that's positive 6. Here's the thing. I divided by a negative. So I'm going to take my sign and just flip the direction of it. I'm never going to go from like greater than to less than or equal to. If I start with an or equal to, I'm going to end with an or equal to. So right now it says less than or equal to. I'll flip it to greater than or equal to. So I get p plus 1 is greater than or equal to 6. To finish solving, I'll subtract 1 from both sides. And my solution is p is greater than or equal to 6. Oh, to 5. Sorry, not to 5. Not to 6. All right. Last step, I need to graph that. If you'd like to check some answers, like I did in green for the last 2 examples, that often ensures that you're shading in the right direction. If you're comfortable figuring out which direction to shade without checking your answers, that is okay at this point. So I know p is greater than or equal to 5, which means I'm using a solid circle at the number 5. I want the numbers where P is larger than 5. So I want 6, 7, 8, not 1, 2, 3. So I'm going to go away from 0 in this case. So I always want you to think about which direction to shade by thinking, hey, what values make that true? So 10 is bigger than 5. I want to go towards the 10. At this point, please flip over your paper and try the next 3 problems on your own. When you're done with those next 3 problems, watch the video answer key to check them. You don't need to watch the whole video if you got them right.